In this video, we are going to talk about cross sections of 3D figures. So cross sections are just formed, they're diagonal sections in a 3D figure. Most of the time we're going to use Pythagorean theorem or SOHCAHTOA, but every now and then we will have to use sine or cosine rule. So on this first one, we want to find the length of diagonal DF. So if you look here, here's our right triangle with DF. So if we set that triangle up, the sides we know are 6. DF is what we want, which is X, but we do not have BD, so that's why I put a Y there. So the question is, how can we get that? Because we do need it to find that length of DF. And if you look at the base, you have another right triangle, which you have those two side lengths of 4 and 5, so you can find BD, which we labeled as Y. So starting with that one, we have 4 squared plus 5 squared equals Y squared. So Y squared is 49, so Y is 6.4. So now that we have Y, we can plug it into our other triangle, use Pythagorean theorem again, and then get a length of 8.77 for DF. So next we want to find the angle size of BDF. So we're using that triangle we had before. We now have all three sides. We have 8.77, we have 6, and we have 6.4. We want to find the angle measure at the vertex of D. So we can use SOHCAHTOA, or you could use cosine rule. Personally, I'm just going to use SOHCAHTOA. I prefer sine, so sine equals opposite side is 6 over hypotenuse of 8.77, and we get an angle of 43.2 for angle BDF. Now, you could use sine, cosine, or tangent using SOHCAHTOA, or you could use cosine rule, and you should get the same angle measure using any of the three options. So next one, we want to find the angle of NEM. So I have this triangle set up, and honestly, that's all we know. We have the full side length of HD is 6, the full sides of BC is 5, and then or DC is 5 and BC is 4, and we're given that M and N are the midpoints of those segments, and then we can use those sides, and their parallel sides are also the same. So the first thing is we need to find our three sides because we'll have to use cosine rule. So first with ME, we're going to use that right triangle there, and again HD, that whole length is 6, so since M is the midpoint, it cuts it in half, so HM is 3. HE is the same length of BC, so we can put 4 there, use our Pythagorean theorem, and we get X to be 5. So next we're going to do EN on the other side. On this one again, FN is half of FB, so that's 3. FE is the same length as DC, which is 5. Use Pythagorean theorem to get Y, and we get Y to be 5.8. So next, if you notice, MN doesn't really have anything with a right triangle, but it is parallel to BD, which means they are equal. So we can use the right triangle with BD to find MN. And so those side lengths are 4 and 5 that are given to us. The hypotenuse is what we want to find, Pythagorean theorem, and we get C to be 6.4. And again, since BD and MN are the same, we can put 6.4 there. Now that we have all three sides of the triangle, we can now find angle NEM using cosine rule. Now the side across from the angle we want is 6.4, so in our cosine rule we need to make sure we subtract by 6.4. Put it all in your calculator, then do inverse cosine to get 72 degrees for angle NEM. So on this example, the first one is we want to find the angle between BE and the base of ABC. So BE is that slant height down the right side of your pyramid, and then with the base, so you're going towards the center. So there is our right triangle right there. We know the height is 10, but that's about all we know. So OB is half of CB. So we can find the whole length of CB using Pythagorean theorem because it's a right triangle. And then since CB equals 9.4, OB is going to be half, which is 4.715. So now that we have two sides of our right triangle, we can use SOHCAHTOA to find our angle B. So in this case, we have our opposite and our adjacent, so we use tan theta equals 10 over 4.715, do inverse tan, and we get our angle measure to be 64.8. Next, we want to find the angle between the edges EB and EC, and if we notice, those are slant heights down our pyramid, which means that they are the same length. It also means that straight down, our angles are getting bisected. We already know angle B is 64.8, so we can find that top angle by doing 180 minus 64.8 minus 90, and we get 25.2. So since EB and EC are the same length, they are that slant height down the pyramid, that means that they are isosceles, so those bases are the same. So those top two, where I have the curves, have to be the same. So if x is 25.2, we add that one more time to get the full angle of EB or BEC, and we get that to be 50.4 degrees. The last one we want to find is angle EMO, where M is the midpoint of AC. So if on this one, we have 4 because it is half, MO is half of AB. So then that whole length is 8. So then that would be 4. Our height is 10. So then we have tan of 10 over 4, theta equals 68.2.